Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my sessions. In this session, we are going to discuss the continuation of the last session, that is Mac layer. We learned the importance of Mac. In this session, we are going to learn different channelization mechanisms. So, before entering into the session, our anthem is Let's crack GATE ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited with India's largest learning platform and recorded courses from India's best educators. My dear friends, as we all know that Unacademy has created wonderful digital platform with a top quality content to serve the dedicated students. And myself is Srinivasarao Sir, having more than 15 years of experience in the GATE with the various papers. I also had industry experience in the database side and the systems side. So with the relevant good certifications in DB, network and Cisco. Dear friends, throughout my journey of GATE, I taught in many premium GATE academies with a high success rate. And many of my students are settled in topmost positions. Either are they PSUs or in software companies. This is all just because of clearing GATE examination and they got completed their post graduation from India's topmost institutions like IITs, NIITs and central universities. Cracking GATE examination requires a lot of training and lot of tips and shortcuts and proper guidance. This is very much important. Guidance is also important. What to attempt, what not to attempt. That is a very important point. So, Unacademy is providing all these kind of skill sets to you, that tips and shortcuts and proper guiding, as well as 1:1 personal training to use also Unacademy is ready to provide. Dear friends, Unacademy is brought forward with two flavors of subscriptions, Plus and Iconic. So Iconic is inbuilt having Plus course. In addition to Plus course, we are also having 1:1 personal coach. So utilize this unique program which is providing by Unacademy, that is Iconic, and see that you are going to get a proper guidance. So the learning program is available in a Plus program and the guidance is available only in Iconic batch. So utilize this opportunity what the Unacademy has created a new flavor that is called Iconic, which is very beneficial to you. So according to Plus, there are three varieties of subscriptions. So if you use my referral code, it describes that you are going to join under me. So when you join under me, then I can able to provide a complete guidance, and my alumni students are also going to help you that their experiences and how they have cracked the GATE examination, because some of my students got cracked single digit ranks also, double digits. So that's why my dear friends, don't forget to implement my referral code, then only I can able to provide this kind of guiding programs. And if you apply my referral code, then you are going to you get the prices like this. And the other one is Iconic batch. So 24 months is a long-term coaching. The students who are first year and second year, third and fourth year even can prefer long-term coaching because first year onwards, if you start your GATE training program, you will get in-depth learning in your area of subjects. Like in first year, you study data structure and algorithms and flat compiler design, DBMS, OS, and many other subjects. That starts from first year and it goes to the B2. That is a third year. So that's why you better opt for long term. And those who are currently would like to access, so you can go for 12-month subscription. So according to Iconic, there are two other subscriptions. That is 12 months and 24 months. So my referral code is also eligible in this. So utilize my referral code and get it admission into Unacademy. So these are the final prices. And my referral GATE and ESE, you can also use for any kind of course which is there. Still any doubt regarding the programs and regarding your syllabi, and just by filling this form, then Unacademy is going to allocate able to assist you, or the faculty member is also going to come to assist you and to explain. Member is also going to come to assist you and to explain everything. So let's crack GATE CSE. Click the bell icon for latest notifications and updates, and use my referral code to get admission into Unacademy. Dear friends, let us start the session, that is channelization. So last session we learned about multiple access. So when you are going for multiple access on a shared channel, then there may be a chance of collisions. These collisions can be controlled with the help of an arbitrary mechanism, that is a medium access control. So which is coming in a different protocols and different mechanisms. One of the mechanism we are going to discuss, that is channelization. So the other one is multiple access protocols. The other one is multiple access protocols. So these multiple access protocols we are going to learn in the upcoming session, and today's session is only channelization. So what is a channelization? So we want to see that there will not be any kind of much more collisions, or we want to see a situation that zero collisions we want. So how are you going to get the zero collisions? The zero collisions you are going to get just by tuning the channel. How are you tuning the channel is the concept of channelization mechanisms. The channelization mechanisms are: number one, frequency division multiple access. Entire bandwidth is divided into different frequencies. And each frequency is assigned to individual nodes. That's it. You got your answer. What is your answer? If I am taking radio broadcasting, so if I am taking radio broadcasting, we are having a different frequencies. 92.5 FM and 92.8 FM. So many kind of FMs are available. That means, what is the meaning of that? A is logically divided into single channel is logically divided into multiple parts. Single channel is logically divided into multiple parts. Therefore, what will happen? If you look at the diagram is like this. This is your shared channel. This shared channel, many of the nodes get connected. Node 1 can get connect, node 2 also can connect, node 3 also can connect. So before they transmit the data, what we are going to do? The MAC is trying to provide a channelization mechanism such that you are not going to have a concept of what? Collisions. So what the MAC is going to do? The MAC is implementing channelization schemes to the nodes who are connected to your particular shared channel. Now here what is going to happen? For example, there are two nodes are there. Assume node 1 and node 2. They are asking the MAC provide a frequency to us so that we can able to access the channel. So immediately the MAC is going to split your channel into different frequencies. One is a frequency 1, it can be any number, no problem. And the other one is a frequency 2 I am taking. Now MAC is saying to node 1 that I am allocating to you frequency 1 as you are requesting for frequency, then immediately the MAC divides entire your channel logically into two parts, and one part is given to each node. Now node 1 is given a frequency 1 and node 2 is given a frequency 2. That's it. What do we understand? As the frequencies are divided logically, logical parts, your physical channel is divided logically into two parts is the concept of what? Channelization. So here what is going to happen? The FN1 can able to access the channel through frequency 1. You need to tune to that frequency, otherwise you cannot get the channel. Like your TV also, television also, you are having Star Network, ESPN Network and many other channels, Sony and GTV. Each is having its own frequency they are going to run. So therefore what happened here? Whenever N1 would like to send the data, it is using this frequency. Whenever N2 is sending the data, it is using this frequency. As the frequencies are differ, then what will happen? The N1 data is being transmitting in the particular logical part only. This is how. And whenever N2 send the data, I am using a different font. Whenever N2 send the data, and his frequency will not overlap with other frequencies. So therefore, he is having node 2 data and node 2 data and continues. This particular part is having only the node 2 data only. So this is what is the meaning of frequency division multiple access. That means nodes are access the channel. Nodes are accessing the shared channel. That's why it is called as a multiple access. But what is the logic we are using? We are using a frequency division multiple access. A single shared channel only, but we are using a different frequencies. As the frequencies are differ, then your data packets are not being collide with the other kind of node data packets because different frequencies are available. So my dear friends, what is FDMA? So FDMA is the available bandwidth is divided into frequency of bands. So each station is a band to send its data. Band is nothing but one small portion of your available bandwidth. So each band is reserved for a specific station and it belongs to the station all the time. So if n users are there, then the spectrum is going to divide it into n equal sized portions. Then each user is assigned a equal portion. So the available bandwidth of the common channel is divided into frequency of bands that are separated by God bands. As I already shown you that how your channel is logically divided. It's not physically divided. Your channel is logically divided. So each station is assigned a fixed frequency of band. A station can transmit data only in the given frequency of slot. Each station also uses a bandpass filter to confine the transmitter frequencies. So to prevent station interferences, the allocated bands are separated from another by small guard bands. So FDMA specifies a predetermined frequency of band for the entire period of communication to the node. This means that stream data can easily be used with FDMA. So FDMA on the other hand is an access method in the data link layer. The data link layer in each station tells its physical layer to make a bandpass signal from its data passed to it. So finally, what do we understand? It is very similar to frequency division multiple access. So when you do frequency division multiplexing, it is done at physical layer. Now we are doing the same concept in the data link layer with the help of frequency division multiple access. So, my dear friends, the bandwidth is used efficiently and collisions are free, but there are some drawbacks also. So what are the drawbacks? We will see now. Unused transmission time in frequency bands goes idle. A frequency is assigned to only one node. Once the frequency is assigned to node 1, cannot be assigned to some other node. If a node not using the frequency, then that particular frequency is wasted. That means the spectrum is going to be wasted, that part what you are allocated. If a node is idle, then bandwidth is wasted. So let us see, it's a diagrammatic situation. So these are the frequency of the bands I am creating from your spectrum. This is your complete bandwidth, and your bandwidth is completely divided into different spectrums. So your bandwidth is divided into different small frequency of bands. So band 1 and band 2, this, another and another and another. They are all frequency of bands only. Now you see, the first frequency of a band is allocated to node 1 or station 1. Next frequency of band is allocated to node 3, and next node 4, node 5, node 6. What do we understand? 6 stations are accessing shared channel. Collisions will come. So to avoid the collisions, what are we doing? We are using a division multiple access. The division is based on frequency. So your entire bandwidth is divided into frequency of bands, and it is allocated to the number of stations who are there in your network. Now you observe carefully, node 1 is busy in transmission of your data, but node 2 is idle, and node 3 is busy in transmission of data, and node 4 is also busy in transmission of data. Node 5 is idle, and node 6 is also idle. Therefore, what will happen? the portion of the bandwidth which is allocated to N5, N6 and N2 are wasted. This is the point. So if at all nodes are transmitting data within the given period of frequencies, then bandwidth is effectively utilized. But whenever who is not interested to transmit the data and their bandwidth is not being utilized properly, and this bandwidth, the portion of the bandwidth which is allocated to node 2, unless and until you disclose it. So therefore, my dear friends, so the frequencies cannot be exchanged between the nodes. It is a fixed. So that's what the points I have told you. What is that? Unused transmission time in frequency bands goes idle. A frequency is assigned to only one node that cannot be switched to other node. Therefore, the unused frequency band, the bandwidth is going to be wasted, which is allocated to that particular frequency of band. Nowadays, we are having different varieties of frequency of bands. So I will tell you, if you are using a Wi-Fi, naturally we are using a 2.4 gigahertz. If you are using a BSNL, its frequency is a 2.5 gigahertz. If you are using Airtel, their frequency may be the different. So these are the different varieties of the frequency where you don't have any kind of collisions, but there may be a chance. What may be a chance? This is your network. Regularly you will find this problem. This is your network. And this we want to have the bridge. So I am having the bridge from here to here. So I am following 2.4 gigahertz if I am following. So when you are having a 2.4 gigahertz channel, they can able to communicate. But somebody between them, so on overhead I am talking, somebody between them is also using 2.4 gigahertz. Then what will happen? Whatever data you are sending using 2.4 gigahertz, and this is also same, so they are having collisions. So if at all frequencies are same given to different nodes, again there may be a chance of collisions, because what will happen? Please see what will happen. As I have divided your channel into two particular logical channels like this, and N1 is using this part and N2 is using this part. If at all their frequencies are same, if I am using 2.4 gigahertz here and other guy is also using say same frequency 2.4 gigahertz here, then whatever N1 is sending and whatever N2 is sending, they will be under ultimately collide because both are following same frequency only. So it's not completely free from collisions because of this reason. What is the reason? If nodes are using the same channel, or if though the nodes are using the same channel with the same frequency, then there may be a chance of what? Collisions. That's why to avoid these problems, we are strictly using time division multiple access. Again, I'm telling you, please look at this diagram carefully. What is that? I have divided. For example, my total bandwidth is equal to 100 Mbps. And in my network, I have got 4 nodes. So I need to equally distribute them. So your 100 Mbps is equally distributed among 4 nodes. Then everybody is going to get station 1 got one frequency which is a capacity of 25 Mbps. Station 2 also got different frequency with 25 Mbps. Station 3 also 25 Mbps. This is how the frequency consists a small portion of bandwidth and it is also 25 Mbps. If all the stations are every time they are busy in transmission, no problem. I am able to utilize my 100 Mbps carefully and effectively. If any particular node, let us say that if he is idle, then I cannot use his 25 Mbps with me. I am using only small portion of your bandwidth only. And these frequencies, whatever I have allocated, F1 I have given, to this node F2 I have given, and F3 I have given, and F4 I have given. And they are completely protected using a what? Guarding. So those frequencies are protected using a what? Guard bands. Already these points are given. Please once go through them. So the signal must be created in the allocated band. There is no physical multiplexer at the physical layer. Everything is done by data link layer only. The signals created at each station are automatically bandpass and filtered, and they are mixed when they are sent to the common channel. But they never collide. Please see that. He is transmitting data and other guy is also transmitting the data, but they never collide. Why they never collide? Because you are coming with a frequency like some frequency 1 and other guy is using a what? Frequency 2, and they are not going to be collide. This is the N2 and this is your N1. Now let us see the second variety of multiple access channelization technique is a time division multiple access. Very important this is. So where are we using FDMA? FDMA we are using in TV broadcasting and radio broadcasting, and your see that mobile communication. They are all based on your frequency division multiple access. So whenever I say time division multiple access, now your time is split into small intervals, and these tiny slots are going to be given to each node. What is the benefit? I will directly first of all give you a figure. You see that I have got a shared channel, and this channel capacity is 100 Mbps. I am saying capacity is equal to 100 Mbps, and the two nodes are get connected to that, node 1 and node 2. Now node 1 can use complete 100 Mbps and node 2 also can use complete 100 Mbps, because I am not dividing your spectrum into smaller parts. I am dividing time into smaller parts. Therefore, duration of your time, for example, I say that 9 to 10 N1 can use the channel, and that time slot we will not give to node 2. So 10 to 11 other node can able to use it. So 1 hour duration, the nodes can able to exchange each other, and this is under round robin fashion. What is that? 1 hour N1 can fully use, and after 1 hour N2 can fully use. Again turn will come to N1 and it goes to N2. So the time division multiple access is in the form of mechanism. An entire nodes, but based on your time duration only, time intervals. So therefore, N1 is given time 1 and N2 is given at time 2. So duration of time 1, T2 node 2 cannot send, and duration of node 2, T1 cannot send. If they send, again there may be a chance of what? Collisions. That's why, my dear friends, what are we doing? So N1 can send the complete channel. N1 can utilize the complete channel duration from 9 to 10. That means particular time interval. After N1 got successfully completed, that means 1 hour time is completed, next turn will come to node 2. And node 2 can able to use a complete 100 Mbps of channel, complete 100 Mbps of channel. Then after your turn, then T1 is going to come into the picture. Therefore, dear friends, observe carefully here what is going to happen. Your time is divided, not the frequency or not the bandwidth. Time is divided. Time is divided into smaller units. these are called time intervals or time slots. That's why as a time is dividing, it is known as a time division multiple access, and every node is going to given a one time slot. Only within that time slot only a node can able to send the data, and you cannot overlap other particular node slots. Okay, friends. So what are the important points? The station share the bandwidth of the channel in time, and each station is allocated a time slot during which it can able to send the data. So divide the time into slots. Each station transmits its data in assigned time slot. Access the channel in round robin fashion. In TDMA, the bandwidth is just one channel, that is a shared timing shared between the stations.